suffering through. I'm sorry about that. Um, all right. I see everything going out to everybody as it should. Hello, everyone, and welcome back to yet another hour of the CosmoQuest Hangoutathon. We are now in hour 20 of this weekend's event. We are working to raise money to allow our team to continue doing our science research, outreach, and journalism to bring you all that is new in space and astronomy and an opportunity of working to help discover what will be new tomorrow as we continue to explore our universe together. Thank you to everyone who's here and cheering us on and saying hi in the chat and supporting us and spending your weekend, your Sunday afternoon, evening, wherever you are on the planet. It might be Monday morning where you are. Thank you for being here with us. Joining me this hour is planetary scientist Sarah Milkovich. She's someone who has a history of working with missions, of being part of getting out there and exploring. And I'm going to spend this next hour talking data and dreaming of data manipulation because that's kind of where my heart is some days. Welcome, Sarah. Can you tell our audience a little bit about what you've had the opportunity to be part of over your career? Yep. Wait, hold on. I'm being told that we have a muting problem. Can you say something, Sarah? Why would that be muted? Oh, I see what happened. All right, it is now fixed.
Okay.
All right, I'm so sorry, Sarah. Can you talk
Um,
about what you've been doing again?
Absolutely. So I have spent many years in spacecraft exploration of the solar system in various forms, starting as a research scientist and then slowly reinventing myself as an engineer, specifically a science systems engineer, where I got to be a scientist embedded in the engineering team for a handful of different spacecraft. So I'm just going to list them: Mars Phoenix, Cassini at Saturn, Mars Reconnaissance Orbiter, the Curiosity rover, and then finally I was on the Perseverance rover from Science Definition Team starting in about 2013 through to the end of prime mission on the surface of Mars.
That's cool.
So, yeah, and it's just a delightful roller coaster.
And Phoenix, it had, first of all, the best logo of any NASA mission ever.
Absolutely, 100% agree.
And this was the rover where they'd started taking a risk in public communication of science. A lot of it started with Lynn Kaminsky's group up at Sonoma State, where they were working with Swift and Fermi when it was still glassed. And during the development of these two missions, they developed these, it was MySpace in the beginning, personalities of these sibling missions planning to explore. And so this idea that you can personify a mission really began to take hold. And when Phoenix came along, it was in the early days of Twitter where it was the Wild West and the people that you were working for had no idea what Twitter was, so you could get away with stuff. And the voice behind the Phoenix Landers account was communicating what your research team was discovering from a first person perspective that was brilliant. And so it was this moment in time where Comet Fairy, share the link to the Phoenix patch in chat. It is it is indeed, as you put it, a whole vibe. I have a mug of it. It is the only mission I have a mug from. And like I've been part of other missions and don't have mugs, but that one. Um, so the Phoenix team, first of all, proved there is frickin' water on Mars.
Yep.
No denial possible. And did it in a way where there was a cover of Wired magazine discussing the loss of that mission to cold. And it was heartbreaking and we mourned. And what was it like being part of that?
It was it was so it was my first operations job.
Yeah.
It was a childhood dream come true that suddenly I was doing all the things that I had imagined. Hang on, I just gotta turn off one thing that clicked at me here. Okay. And so it was I didn't really know many people because I had kind of joined the team about a month before landing.
Okay.
So, and then we all moved to Tucson, Arizona because it was being operated at University of Arizona. And so I rented a little apartment on the edge of town and put tinfoil on the windows because it was also my first time experiencing Mars time.
Yep.
We were living the 24-hour and a little bit more life of operations. And so for me, the excitement of the mission is all tied up with all those the emotions of starting a new job, of moving to a new place just temporarily. There are so many, when you are living on Mars time, so you are perpetually jet lagged.
Yeah.
You start your day like so on the Spirit and Opportunity rovers. They were on Mars time, but they were on a very strict, like rigid shifting. This was Mars time with talking to an orbiter instead of talking directly to Earth.
Oh.
So our start time actually it was a window that shifted, and so we could start maybe 15 minutes later, maybe an hour earlier each day. You just really didn't, and kind of found out when you had to clock in. You kind of found out like the day before. So we were all kind of a little loopy after a while. So I have like, there was just a lot of like the camaraderie that forms when you're in a small room. Nobody else is working on the same schedule as you, and you're seeing the same faces all the time, and you're doing something so exciting is immense.
Yeah.
And I remember you were talking about the discovery of water. When we finally truly confirmed, like we were guessing that it was water for a number of days, and when we finally had the data that it was water, Bill Boynton, the PI of the instrument, he had gone, I think he'd gone to like a thrift store and he'd found a witch's hat. And he walked in to the first big like joint where the science team is handing the plan over to the uplink team meeting, wearing this witch's hat and saying it's water, because he's now the Wicked Witch who melts underwater. And I think he may have worn it to the press conference later that day. Somewhere there is a picture of Bill Boynton in this like purple witch's hat. So
I love that.
Hopefully somebody can go find this.
So in the chat, Bill Nash is like, I'm going to shout, we found water on Mars. The next time the shake machine is busted at McDonald's, maybe Shame will get them to fix it. And he goes on to say, I'll be sure to enunciate clearly so there's no confusion when they give their statement to the police, to which I responded, I love that for the people in that McDonald's.
But I did want to highlight, you mentioned Twitter, like the
Yeah.
Phoenix mission to follow that account was why I signed up for Twitter originally. Um, and I remember like the closing few statements that they put out.
Yeah.
And I was no longer, I had, once we hit, 90 days, a bunch of us shifted off to other missions. And I had gone home and I had started work on Cassini, but
Hmm.
the tweets that I remember, um, it was the the personification of
Yeah.
the spacecraft of the lander, like trying to
Yeah.
reach out and saying, you're not always going to hear me. And then there was there was a string of binary
Yeah.
that was tweeted.
Yeah.
And when you translate that binary, it went to "this was a triumph,"
Yeah.
which, and that was the same, that was right when Portal came out. So the song, the Still Alive song at the end of Portal, we were all like, I think it had been out for a while, but it was still in the pop culture. And so it was just like there was something about that bringing together the some of the sort of nerdy pop culture that was still going on,
Yeah.
the personification, and it just made it so, and putting it in binary made it
Yeah.
so easy to visualize this little this little robot still trying to talk to us.
And what I loved about this mission was there was that message of I'm not always going to be here with you, but I did what I was meant to do.
Yeah,
And and there's so much that can be learned from that in so many different ways. And this idea that we each just have this moment and we need to do the things we're meant to do is we're all inspired to be better humans by a lander on Mars. Now, what really gets me is Spirit, Opportunity, Curiosity, Percy all have this amazing stereoscopic vision. They're roughly human height, depending on height of human and which rover you're talking about. You can find one to match each. Um, and so we now are starting to have a human scale perspective that can wander the countryside on Mars. What what kinds of data products are getting taken? 'Cause, like, I'm sure there are things that I just have completely forgotten over the years that you must have just had that moment of, and I shall look at this. Ooh, that's cool.
I think one of the things that we tried to bake in from the beginning, starting even at the definition team, the
Yeah.
science definition team for Perseverance, was we needed to have, we knew we had so many different cameras at so many different scales, going from, nav cams and Mastcam Z with the being able to do panoramas of the
Yeah.
countryside, way down to Sherlock, and then the Watson camera on
Mhm.
Sherlock, which is the handheld microscope, and then with the Sherlock spectroscopy and with the Pixel instrument, and they each have little context imagers inside them in
Yeah.
addition. Like everybody's kind of like, I remember one of the engineers was like, wow, it's like a 12-year-old slumber party on this rover because everybody's got a camera.
Mhm.
And what we had on previous, we came in with experience from all these different missions around Mars, where you have
Mhm.
this, especially if you're not a Mars scientist and you're looking at the Mars fleet and you're like,
Yeah.
you guys have so much spacecraft. It is really hard to take data from one instrument
Yeah.
and co-register it with the data from another instrument. And you need, but by putting all these different, not only different cameras, but different like
Pixel
placement.
scales, skewing. There's
Exactly.
ridiculous problems like optics are never perfectly flat. So if you
Right.
take a picture of graph paper, the squares aren't all actually equal in most optics, and trying to correct for that is a special nightmare.
So we wanted, so that at the very least, we wanted to be able to say, this measurement, this, 150 micron laser shot from one of our, geochemistry instruments
Yeah.
is in this pixel on in Watson, which is in this pixel in Mastcam Z, which is in this specific location, so you can find it in HiRISE from Mars Reconnaissance Orbiter.
Yeah.
And that, it turns out, so we had to, because I knew from my own past experience, my own research experience, trying to line up just Mach and MOLA from Mars Global Surveyor. Um, so I was part, because I was in the science, I was so connected with the science team, I was able to push that into the engineering team
Hmm.
and essentially force them to do a set of calibration experiments before launching the rover. Like we had to
Oh,
really,
cool.
because you have to be like, we need this knowledge to this precision level, and you have
Hmm.
to emphasize it as much as possible, bake it into the requirements, which means that it goes into the testing. Because when you are in the crazy mad dash
Yeah.
to the launch pad,
Yeah.
you have, you start out with this beautiful vision, and then it's like, for anybody who's seen Howl's Moving Castle,
Oh, I love that movie.
like towards the end, when the castle is running and bits of it are falling off as it's running, you're trying to get to the launch pad, and everything's being stripped down to
Yeah.
what is the minimum viable product that we can launch and be successful. And we no longer have time, money, or people to do the extra shiny things.
Yeah.
And so the fact that we got this capability, and we also got some of the tools on the planning side that are able to pull in these information so you can target off of each other's data. Like, all of
Hmm.
this is something that I'm really proud to have been just a little cog in that
Yeah.
machine to make it happen, so that hopefully it makes researchers' lives that much easier. Because we always know that you
No, that's
learn
Allie's.
you can learn a lot from one data set, but
Right
you
there on the floor.
learn so much more when you put two different data sets together.
Yeah. Sorry for the chaos. Annie Wilson, one of our community members, has brought me beautiful,
Ooh.
beautiful, beautiful food I'm not allergic to. Um, and that is strangely difficult. I have a severe allergy to this protein that's in a whole lot of fruits and vegetables, and having people not kill me is strangely exciting.
You would like to not kill you.
It's a goal. It's a goal. We have a no death policy around CosmoQuest, and I want to, now that I've interrupted, um, I don't know if you know Stuart Robbins. He made a catalog of millions of craters on Mars for his doctoral
Mm-hmm.
dissertation. And we're working with him on a project right now where he is going through and writing algorithms to reprocess CTX data from Mars Reconnaissance Orbiter to better match the backgrounds of the image, because we have enough data over all the years that we should be able to build a global mosaic for each season, a global mosaic for each year. And these should allow us to see new things that occur season to season, year to year. But in order to be able to set machine learning loose to say, these things exist in this mosaic, they don't exist in this mosaic, we need to get the mosaics to actually like have the same background levels, to have the same pixel scales, all of these different things. And that's super hard to do. And algorithms get confused by the stupidest stuff. And so we run into problems where you can have two images of sand dunes, so fuzzy, not a lot of detail, that are off by 20 pixels. And when you difference them, because it's just like dunes, you don't really see stark contrasts. And the algorithm's like, yeah, this is a match. But you look at it with your eyeballs and you're like, no, it's not. But at the same time, if you have a perfectly aligned crater and the sun moved, so the shadows move, and you have these stark shadows that are in a different place, the algorithm will like be like, wrong, you screwed up. No, that's actually just the sun moved. I mean, the sun didn't move, the planet rotated and moved, but the shadow angle moved. And so
Yeah,
we're
and
asking human
it's
beings
a
to get
challenge.
involved.
It's a challenge when, I mean, with CTX and HiRISE, that is also a spacecraft that it rotates as it takes
Yeah.
and so and it's um so the angle, I mean, it's what allows us to do stereo imaging
Yeah.
with it, but at the same time it makes it, I'm sure, harder for any kind of automation of that kind of processing, because you're like, the sun angle is different.
Yeah. Yeah. And so we're always trying to find new ways to put all these different imagery together. And one of the things I dream of doing, and I'd like to ask you to dream with me, because sometimes it's good to just imagine what could we do. So, have you ever got to play with a VR headset, like an Oculus or something like that?
Yes, we use them in Mars planning.
Mm,
And we so the a lot of the rover planners have a 3D setup. And then what we were, again, like I said, the bells and whistles, and you dream big at the beginning, and then
yeah.
you get forced into the practicalities of time and money.
Hmm.
We had originally a plan to build out the ability for our science team to do planning and target selection within the VR headset.
That's
And
amazing.
it so I think that the hooks, I it's been it's been several years since I was on the project. I think we had done a lot of initial studies, and then we had to kind of put them down and make sure we had fundamental capabilities in the
Yeah.
software. So I'm not sure if the hooks are still there, but it was um, definitely, I know that some of the engineers, before they went in to actually assemble the spacecraft, the
Yeah.
rover, they would look in the VR world at like, how are things, we gotta this is gonna fit in here, how are all
Hmm.
these things gonna fit together. So and this was back in, let's see, well, we launched in 2020, so this was
Yeah.
several years before then, but it was in that time period. I don't know where it has gone since, but we had this idea, because our one of our fundamental challenges
Hmm.
is that have uh, we have a very large science team.
Yeah.
It's when I left, it was about 500 people, all around the world,
Yeah.
and we with with Spirit, Opportunity, and Phoenix, they were able to do and Curiosity, they were able to do a co-location. Everybody came to Pasadena.
Mm-hmm.
In Curiosity's part, it was for the first 90 days, and then everybody went home. And so in those 90 days, you work together and you really bond as a team. And so then when you're trying to do planning over the phone or over Zoom, it helps you have that camaraderie,
Yeah.
especially when you are disagreeing on what you should do with your spacecraft, disagreeing on what the data is telling you, and
Yeah.
also trying to understand people who have a variety of different first languages, and you're all attempting to communicate together.
And jet lagged. Don't
And,
forget how much of an
and
that impacts everything.
so the folks on the team who are in Australia are always at this, calling in at just crazy hours for them compared to, because we're trying to get
Mm-hmm.
good hours for the US.
Mm-hmm.
So we had this idea that you could use essentially a VR room where it was you put on a headset
Yeah.
and it would turn your office into Mars. And I think
Mm-hmm.
Curiosity may have some of this that they play with. So you would be like you're standing in your field site as a field geologist in your location on Mars. And you could have, so how would you show your eye line to somebody else who's
Yeah.
in the same, standing in the field location, saying, I'm looking at that rock over
Mm-hmm.
there, so that you both can come and look. And so that was some of the ideas that we played around with a lot early on. And so hopefully some of that, you never know where these ripples of ideas end up.
I I had no idea this stuff exists, and you have no idea how I've been streaming a lot and I've been presented food, so my excitement about the science things that you're teaching me is not showing appreciably because also egg. Egg
No,
is
you need
exciting
to
right
keep,
now.
you've been doing this. What is this? You said hour 20. You need to keep your energy levels up.
Yeah, yeah. So we have 6 more hours after this. Um it's a lot, but it's worth it to keep this community going. And one of the things that we dream of doing is I've good ideas often get brought up over and over until someone is able to prove that it was actually a bad idea. Don't fight a land war in Asia. Or someone is able to solve the problem to do the amazing thing. And one of the things that I've seen come up over and over, so Ben Boatwright, Dan Bierman, I've completely forgotten the name of one of my colleagues from Trex, whose initials are E and D, and that's not useful, but I remember you, human, whose name has escaped me. Each independently came up with the idea of using the Mars rover stereoscopic data from the various rovers to make it possible for people to do geologic field trips on Mars, to make it possible for people to do the kind of field work that geologists are trained to do, but in the VR landscape. And this is the kind of thing that, as an astrophysicist, I have to admit, I didn't fully appreciate. But a major part of the training for geology is like going to roadside cutaways in the rock and looking at the sedimentary layers and looking at the way things crumble and just looking. And you don't actually have to touch. Please do not lick the geology, people. I know you want to lick the geology. Do not lick your rocks. We have a no licking science
Some of them are very
policy.
bad for you.
Cinnabar. Do not lick the cinnabar in particular. Um, so what we really, one day, I was like, I'm a technologist. I do support software work. That's kind of where my day job often takes me, is creating the software that enables other people's science. And I was like, let's just do this. And Dan and I put in a grant, and it didn't go anywhere. The program officer we were working with was in the process of retiring. It was just the wrong moment, the wrong everything. put in a grant with Kirby Runyon to try things out on the ground, doing drone imagery as a trial. And program officer was like, yeah, you're going to a lunar, surrogate's the wrong word, a lunar place on Earth that's the same as the moon, but isn't the moon.
Analog.
Analog. Thank you. Yeah, you're going to a lunar analog, but you're on Earth. This belongs in the Earth science, not the astrophysics part of the NSF. So this is literally a project where we haven't actually made it to peer review because we keep hitting program officer issues. And what
Let me tell you about, so we had, when I was in, so this is way back in graduate school.
Yeah.
We had, do you remember the I don't know if they still have these, they were called the cave. They were like the cave where it was this 3 screens.
Yeah, we had one at the University of Texas.
Yeah. So my thesis advisor worked with the computer science people who were like, we have a cave, what can we do with it?
Yeah.
And so we also had this like, well, can we do planetary field geology using this? So this was back in like 2003. We put.
I'm actually a little older than you.
Well, but I mean, to give you a sense of where the technology was at the time.
Yeah.
So we put my research, was about layered deposits at the poles of Mars.
Yeah.
So ice and dust, and trying to see if we can pull out a climate signal from that. And what we did, and we're working with MOLA topography and Mars Global Surveyor mock images. And we put them in the cave. And then we were telling them about like, okay, ultimately we were trying to get them towards being able to measure strike and dip so that you can measure the angle that the rock is at. So for everybody listening, if you're not a geologist, strike and dip is the fundamental way that you tell if you have, the orientation of your rock is measured in the angles of strike and dip. And so we had gotten to the point where you could lay down contour lines and you could have like a contour level, like sort of like just a level plane that you could move up and down as you stood around, as you walked around. And we were like, okay, and then you've got this thing that you hold, and we were trying to be, okay, you need to be able to like pick out 3 points and then fit the plane to it and then tell us what that plane is. And then I graduated, so I don't know what they did with it afterwards.
Fair enough.
But I think there was one paper that came out, so I can actually send that to you if I find it.
That would be awesome. That would be absolutely awesome. And
see, everybody, this is how real science happens. Yeah. It's people chatting and being like, oh, that makes me think of a thing. I'll send it to you in case it helps further.
Yeah. One of my favorite moments was apparently Jordan, he's one of our PSI scientists. Thank you. His last name begins with an S. It's just going to be that day. Skafaloff. Steckloff. I'm being okay. Allie, my producer, my right-hand human. Jordan Steckloff. So Jordan was he's someone who works on things like what does it take to get a comet active, study centaurs, all that sort of stuff. And he'd worked on software that would allow him to model destruction of asteroids and cometary objects as a function of ice to rock, as a function of temperatures, all this stuff. And he was at a conference and he got to talking to a stellar astronomer. And they realized that they could combine what they were doing to study at what point in a white dwarf's cooling pattern is it possible for rocky stuff to reappear, because a very young white dwarf is extremely hot, giving off massive ionizing radiation, destroying everything around it. And we don't find gas dust chunks, any of that, around white dwarfs that are very young. But older ones, we start to find dust disks around, we start to find planetesimals around. And so instead of looking to see at what point does the sunlight destroy things, he used his code to figure out at what point is rocky stuff able to exist again. And it was really kind of awesome. So, yeah, and that just came out of people talking to each other.
Yeah.
And this is what moves science forward is the what if, the creativity, the laughing and sharing ideas. And accidentally feeding my dog's egg in the background, apparently. I just heard things and very excited dogs went to clean it up. All right.
No, they stole it.
Okay, apparently they stole it before Allie had a chance to even try and rescue her food. All right, dogs have had stolen egg sandwich for dinner. Sarah, I return to what we were originally talking about. So one of the things that Dan brought to my attention that I just hadn't realized is how much of Mars we have stereo orbital data from.
Yeah.
And it's good enough that I worked out back of the envelope scale, and you can imagine yourself at the scale of the Jolly Green Giant on the bag of a thing of steam and bag green beans. And at that scale, on a small world like Mars, that's essentially the 3D reality you're walking in using that kind of data. And you can't see the same sedimentary layers you see if you pull off to the side of a highway, but you can still do science you can't do without retraining your brain to look at images different from how you learned in grad school to look at cutouts in the side of the road.
Yeah, it's amazing the data that we have.
Yeah.
And then if you think, like, we thought about this a lot for also plan, how do you use a spacecraft to do geology? And when you're a geologist walking up to a new place, the first thing you do is you stand back and you look around. You don't immediately dive to a teeny tiny rock and start trying to cut off a thin section or break it with the rock hammer. The first thing you do is you need to look around and get the lay of the land and start building up the context.
Yeah.
And then as you do that, that's how you spot the places that are going to tell you the most.
Yeah.
Because also you can't take your entire outcrop and take the whole thing back to your laboratory.
You can try.
It would be amazing. You also have to have an army of students. But so you got to go be okay, this is the location where I have, maybe I've got a change. I've got two different rocks coming together, or I've got veins running through here. And those are the places where you say, I'm going to take one rock from here and I'm going to look at this. This is what I'm going to investigate more closely.
Yeah.
So we do it on one kind of scale already for Mars, where we have these orbital, we have, now that we have these amazing CTX maps, we can't even say low resolution, because that's compared to what we had, back in the day. That's still amazing. That used to be our high resolution, and now we have high rise to be high rise is 60 meters or 60 centimeters a pixel.
Yeah, it's less than a meter a pixel. It's not as high a resolution as LRO, but it's pretty darn close.
Yeah. And I need to know it because I used to work for them. So we have going. So we say okay, CTX tells us this is really interesting.
Yeah.
And then we can look at it with high rise. And then with a lot of effort, we can build up a mosaic of a particular location on Mars with high rise.
Yeah.
And then we can send a rover or a lander. And once we've done that, then we can start to get, like you were saying before, like the that scale of being a human standing on Mars. And then from there, we can, if we are a rover, we can drive around and be like, okay, I have now driven up to my super interesting rock that this location can tell me a lot about a variety of things in this area. And now we can pull out all of our higher resolution and chemistry experiments. And so that's the, but we only have so many rovers, and like,
Right.
knock on wood, we will get some more. But right now, they're a very limited supply. And so, and Mars has so many interesting things, and it's so interesting not just to a Mars scientist, but by understanding Mars, that's another puzzle piece in solar system formation, planetary evolution. So enabling, like, how far can we get with the data sets that we already have becomes a huge, great thing. There's so many theses that can be written
Yeah.
based on what we already have. And any way that, like, with Perseverance, one of the things we were really trying to push on when we were building our software planning tools was we want to minimize the amount of time that our scientists are wrestling with the tools themselves.
Yes.
And maximize the time that they are thinking about science and working on science. And so anything you can do to make it more intuitive is huge. And so I love this idea of, having the Jolly Green Giant scale walking around the surface of Mars. I love this because, all of us who have a planetary geology style background, I'm going to say a large number of us have had this field experience. And then there's people who specialize in looking around the Earth for the fundamental processes are the same. And so you look around the Earth and be like, okay, I have, okay, I'm going to go to Iceland and I'm going to look at how volcanoes under glaciers look. And then I'm going to look at features on Mars, and I'm going to look for features where it looks like once there was an ice sheet here because of the way the volcanoes are expressed. And like, that kind of comparison can only become better if you can build on your field intuition that you've developed. So I think this is a really great idea.
And this is, sorry, I have an Australian Shepherd that desperately wants what is left of my egg sandwich, having already stolen Allie's. Well, so I have 2 bites left of mine, and he apparently got the taste for egg sandwich when he stole Allie's. And so, yes, no, I have another Australian Shepherd who's like daring to put her paws on my chair. Okay, the vultures are circling egg sandwich at the moment.
I have a Labrador, so I totally understand you have a scrap of food that was briefly on your fingers, and now they want to come be your best friend. So I totally get it.
Yeah, they're singing in the background for this egg sandwich. All right. So insanity is occurring. Hello, Bad Panda Bear. You arrived just in time to hear Malachi singing for my egg sandwich. Yeah, this is something we really want to do. We know of a team, Kevin Russell. He works with the Human Space Program, a nonprofit, not the NASA division. And one of their educational programs is they have 2 sets of VR headsets. I forget. They're not Oculus. I forget which ones they are. And they've set them up to be able to take kids into low Earth orbit and give them the perspective of the International Space Station and the overview effect. And they're trying to figure out if they can engender the overview effect, that life transforming, soul changing moment that we all saw William Shatner have when he came back from the New Shepard flight. They're trying to figure out, can they engender this using VR? And the answer seems to be yes.
Oh, wow.
Yeah. And so this is something that I want to be part of. I want to help with, and it's not an overview effect when you go to Mars, but it definitely gives you an appreciation. I'm laughing because Bad Panda Bear put a picture of Malachi in the chat with musical notes. So I want to be part of helping get people walking the surface of Mars in their VR headsets. My VR headset would like me to exercise more in the Alps or go on mountain climbing journeys in the Rockies. And it turns out, would just like to murder fruit playing Fruit Ninja. That's who I am as a person. But if I can help other people live their best geologist life on another world, these are the things we dream of. And I'm going to be reaching out because you know things I don't know. And I'm going to pry them out of your brain and see if I can coax you into helping us do awesome things, because that's also what I do as a person.
Always in the favor of doing awesome things. Possibly even daring mighty things.
Dare Mighty Things is one of NASA has the what is it? It's not fear is not an option. It's
failure is not an option.
Failure is not an option is one of the NASA slogans. And then Dare Mighty Things was what they used around Curiosity with the 7 minutes of terror going into the landing. And one of the funny things that I ran into is I got a water bottle at Kennedy Space Center with the failure is not an option logo on it. And I put it through the dishwasher and I learned failure is an option, because that bottle failed. And so this is where we dare mighty things, where failure is an option and you just keep learning and keep going.
That, I think, because the failure is not an option came out of the human space flight at NASA, and it was at JPL at Curiosity Landing. The Dare Mighty Things was a quote from, I think, Teddy Roosevelt, that our lab director said in his press conference speech. And then the lab just kind of like grabbed onto it, because for when you're doing these sorts of things, you actually want certain, like in testing, you want things to fail because you want to know how it's going to break so that you can make it better. And so it's on some level, failure is to be expected.
Right. Because
you can learn from failure. And now as a parent of a young child, I try to, embrace this and be like, no, if you're not getting out there and failing, you're not trying new things.
Right. And
it's failure is okay. Failure is there for you to learn from.
Yes. So, and it's also all right to learn from other people's failures. I would just like to add, you do not need to experience all the failures yourself.
Many times it's preferable.
It's true. And yeah, there's so many opportunities out there, so many things to work on, so many data sets that are radically underutilized because there are so few of us and the numbers are going down every day.
Yeah.
And about a year ago, 2 years ago, we started to see, particularly at JPL, the work-life balance was no longer there. There was a question for a lot of NASA events, they ask you to submit the questions ahead of time and people vote on what questions they want to see answered. And there's one put forward by a researcher at JPL. Malachi continues to sing in the background. Howling. There's literal howling going on in the background. So one of the things this researcher put in was, how is NASA looking to address the problem where we are often funded 10 hours a week, 20 hours a week, working 60 hours a week, because we have to be submitting grants, we have to be doing things that are outside of our paid hours, and then we're getting our budgets reduced on things that we've been working on our entire lives, and we can't see them fail. The Viper mission team right now is one of those. They've been working on that since the early 20 teens.
I mean, that was mind-boggling to me. You have built, I mean, by the time you have a built spacecraft, they had a built rover, and then they put it aside. And it's like that, all of the money has been spent, basically.
$500 billion.
It's
Sorry, $500 million.
I was gonna say that would have been
No, it's $500 million, 500 million.
Yeah, that sounds much more reasonable.
I screwed up. Yeah.
But like, like the by the time you get to the launch pad, the time that the science actually starts on a mission, you know, you've spent almost all of your budget.
Yeah.
And it's so, yeah, that was, I'm, you know, just fingers crossed so much for them. I'm like. So
from the people that I talked to, pretty much all of whom had to be off the record, the issue was they didn't trust the Astrobotic rover to hit the launch window, which it didn't. And there was a lot of concern that given the failure of Peregrine, given the failure of everything except for Firefly so far, that it was too great a risk, and it was better for NASA to say, we're going to cannibalize Viper than to launch it and lose it. And this is where they're now looking to have Blue Origin first do proof of concept with their Mark 1, and then say this is how we can deploy it using our Mark 1. So I'm really hopeful right now that Blue Origin is going to be able to step forward to both rescue Viper, which was disappointed by Astrobotic, and step forward to rescue Artemis 3, which has been disappointed by Starliner. They're looking at potentially doing a special version of Mark 1 that will be human rated and accelerate ahead of what they're going to be doing with Mark 2. It won't be as fully functional. It'll be much more Apollo era, but it will be getting us back. And
it's just I am, as someone who's not involved in human spaceflight and someone who is also not a lunar scientist.
Yeah.
But I have a lot of friends who are. And so I'm a very interested bystander. And I'm always struck by how much we end up having to go back to the Apollo concepts. You know, they did a good job.
They really did. Yeah. And they had the budget and enough people. And that's one of the things that doesn't get communicated enough. Yeah. We are too few people doing too much with too few resources.
Yeah.
And
to go back to the work-life balance questions, even so there's the concerns, as a scientist who's living off of grants, like those are the ones you mentioned are very important concerns. For the engineers who are designing and building and operating the spacecraft, there's also the concerns of, first of all, it's hard to come up with a budget for something that's never been done before.
Right. JWST was the poster child for that.
Exactly. And then you go off of, what did the previous closest things, like when we're trying to come up with budgets for Mars rovers, you look at the previous Mars rovers.
Yeah.
And then you say, okay, and we got to stretch by this much. But it's hard to take into account the fact that everyone who works on these kinds of things, there's a long tradition of the closer you get to launch, the more your work-life balance is completely non-existent and you just throw yourself into this. because nobody wants to be the person who lets the team down.
And you may
And
never get this chance again.
you may never get this chance again. And then that just kind of, that gets baked in
Yeah.
on a deep and fundamental level.
Yeah.
That it becomes, you expect that that's what's your life is going to be. And then there's a lot of creep on what that time period that you're doing this, that kind of creeps because nobody's getting, the budgets don't go up.
Yeah. Yeah.
You know, you keep on going and asking for more money, and then, you know, you get some, but never what you actually need.
Well, and
it's
there's
a
this,
complicated thing.
there's, sorry, I have to set something down before the dog drags it out of my hands. One of the last aspects I want to hit on that, and we're running over, and that's fine. This is an important conversation. One of the things that doesn't get talked about is when we're having a flat budget, that leaves you the choice of what do I cut? Because things like my AWS server costs are going to go up. Health insurance, my God, it goes up. Things like travel to conferences goes up in price. And as each of these things goes up in price, and there's usually a 3% cost of living adjustment on my salary, well, all those things add up to I'm now working 1 day a week less than I used to be, expected to do the same amount of work.
Yeah. And there's, as someone who lives in LA, I have seen that the cost of living here goes up faster than salaries.
Yeah.
And I am no longer at JPL or NASA, so all of this is statements as a private citizen.
Yeah.
I saw young people who would move into the area, but they couldn't afford to live anywhere near JPL.
Yeah.
So their commute was very long, and they had larger student debt.
Yeah.
And so it becomes hard to juggle those things, and it becomes hard when, you know, a lot of the people who are making big decisions, they're not really aware. They haven't experienced this, so they're not aware of a lot of these challenges.
Right.
And that's one of the complications of today. That you know, you mentioned there's fewer and fewer people doing this work, and these are some of the many reasons why people end up saying, you know, I loved this. This was a dream, but I'm gonna go try something else.
Yeah. Yeah. And as I wrote in our last newsletter, any of you are getting the CosmoQuest newsletter, I've looked out into my options, and I could be a programmer. I could be a journalist. I am a journalist. Who am I kidding? I've worked as a stable hand, and I enjoy, horses are grateful. And the truth is, what I really want to be when I grow up is a scientist who does research, who communicates my results. And yes, I'm going to keep shoveling shit because that's part of life. And we're here at CosmoQuest trying to find a way to do all of this independently funded so we can keep our DEI content, so we can keep being a place that has no qualms, being openly supportive of all the different body types that are part of our community. We don't care who you are, where you came from, who you love, but only that you find love in this world. That's who we want to be. And so this is where we're doing fundraising like this and trying to find a new path forward that redefines what it means to be a scientist working in collaboration with the public. It's who we are.
You're here.
We are here. Thank you, Sarah. This has been amazing. I learned so much, and I'm going to be reaching out to you so I can continue to learn from you. It's been...
I'm very excited. I'm so pleased. I'm so grateful to come chat with you. It's been wonderful. And yeah, I hope we can keep the conversation going.
Oh, we will. We will. I will not let you fully escape. Thank you. I am now going to roll those rockets, and you're going to see at the bottom of your screen, those of you out there watching, the names of everyone who joined our Patreon community before December 1st at the $5 a month level or higher. I'm looking so forward to adding the names of so many new people next week, but not this weekend. Thank you for being here. I will definitely be talking to you more later, Sarah, and see you all on the other side.